what I want to talk about here is integrating rational functions. So if I have something like this is something we already can do. That's a U sub problem. Done, right? Just using a natural log antiderivative. But what if we have instead something where the degree of the numerator is greater than the degree of the denominator? Now you could check to see if you can factor and reduce, but that doesn't reduce here. So what we'll do is we're going to do some polynomial division, because that'll... You could do synthetic division in this case. Does synthetic division work in every single case?
Yes.
No, it does not. What cases doesn't it work in?
When it's like not just x plus 4.
If it's to do synthetic division, we need to have a degree 1 in the denominator with a leading coefficient of 1.
Oh yeah.
Yeah, like you cannot do x squared plus 4 equal, x squared plus 4 for synthetic, right? Because
Right.
you gotta set it equal to 0 and you're gonna end up with some kind of negative value.
So if I do the long division, it allows me to rewrite it this way.
Yeah.
Now that's easy, right? I have x squared over 2 minus 9x, and then I can U sub here and I'm done. Pretty nifty, right? What if it's the reverse? What if we have the big one on, or the big one on bottom? What I need to, well, what I notice is that this denominator factors, right? So what I'd like to do is I'd like to take this guy and be able to break it up into something that looks like this. Do you remember this from last year? This is called partial fraction decomposition. We did this in pre-calc last year. So I'm going to multiply both sides by x minus 3 times x minus 2. That gives me x plus 4 on this side. And a times x minus 2 plus b times x minus 3 on the other side. I can distribute the a and the b through. So I have ax minus 2a plus bx minus 3b. Now I know that the x terms have to add up together, right? So a plus b has to give me that coefficient of 1 on the x. And similarly, the constant terms have to add together. So I know that negative 2a minus 3b has to give me 4. That's going to form a system of 2 equations so I can solve for a and b. So I could do substitution or elimination. I'll do 2 times equation 1 and just add them together. That's going to give me negative b is equal to 6, or b is equal to negative 6. If I plug that back in, then similarly a has to be 7. Or I'm sorry, a has to be 7. So what I can do then is I can say this is going to equal the integral of 7 over x minus 3 plus negative 6 over x minus 2 dx. So I can U sub each of these separately. So I get the natural log of x minus 3 plus the natural log x minus 2 plus c. Is that okay? That was fast, I know. What if instead now,
Good afternoon, Notre Dame class. As we come to the end of this Thursday, let's stop and reflect on our day. Was I patient enough?
Oh, shoot.
I experienced today?
thank you.
God, please help me grow in patience as I listen for your voice and grow closer to you. Amen. Be careful out there, those of you who are driving.
Hey, just give me 1 sec to finish this one.
Slow down and take it easy. Have a great afternoon.
No, I
Stay
want to
safe.
do.
God bless. Teachers, you may dismiss your
That.
classes as you are ready.
What if I have something that looks like this? It's not factorable. Oh no. Here's what we're going to do.
Could you split up like 6 into?
We're going to kind of try to do a completing the square.
Oh, how do you even do that?
So I'm going to break it up like this, because that piece that remaining is x minus 2 squared. Now I can u sub this with x minus 2. What's the antiderivative of 1 over 1 plus tan inverse? Yes. Those are the 3 different techniques you'd use to integrate rational functions. Those are in the multiple choice.
Will you post that video?
Yes,
Okay.
absolutely.
Thank you, Mr. Klein. Have a good day.
You're welcome. Try to do some calculus over break.